Hello everybody, it's Tarun. Welcome to your fifth tutorial in the CSS for presentation course. So in this tutorial I'll continue with the discussion of values of the font size parameter in the CSS. So I'll start with percentage values. In the example which I told you in the last tutorial, the font size of H1's parent element which is body was not has been specified as 100% of the default text, okay, which is generally 16 pixels. The H1 inherits the 16 pixel size from the body element and applies the 150% font size value, which multiplies that the inherited value, and it will result in an H1 that is 24 pixels. If the user has used font size set to 30 pixels, for example, if you are reading it on a television browser from across the room, the resulting H1 would be 45 pixels, but would maintain its proportion relative to the main body text. So, which is the idea of using relative measurements? Okay. So I'll just tell you relative measurements. Just wait. Okay, CSS provides a variety of units of measurement. They fall into two broad categories. One is absolute and another is relative. So first let's see relative units. Relative units are based on the size of something else, such as the default text size or the size of the parent element. Okay. PX, which is pixel, considered relative in CSS 2.1 because it can vary with display resolution. EM is a unit of measurement equal to the current font size. EX is X height, approximately the height of a lowercase x in the font. So the following units which I am going to tell you are new in CSS 3, and they might not be supported in the browser yet, but some of them could have been. Okay. First one is REM, which is root EM, and it is equal to the EM size of the root element, which is HTML. Then we have CH, it is zero width equal to the width of a zero in the current font and size. Then we have VW, which is viewport width unit, and it is equal to 1 upon 100 of the current viewport, or you can say browser window width. Then we have VH, which is viewport height unit, and it is equal to 1 upon 100 of the current viewport height. Then we have VM, which is viewport minimum unit, and it is equal to the value of VW or VH, whichever is smaller. So this was all about relative units. Now I will tell you about absolute units. Absolute units have predefined meanings or real world equivalents. The first one is pixel, px, and it is defined as an absolute measurement equal to 1 upon 96 of an inch in CSS 3. Then we have pt, which is points, and it is 1 upon 72 inch in CSS 2.1. Then we have pc, it is picus, and 1 pica is equal to 12 points. Then we have mm, which is millimeters, then cm, centimeters, then in, inches. Absolute units should be avoided for web page style sheets because they are not relevant on computer screens. However, if you are creating a style sheet to be used when the document is printed, they may be just the ticket. Okay. So now let's move forward to the next measurement unit, which is EM measurements. And EM is a relative unit of measurement that is that in traditional typography is based on a width of the capital letter M. Okay, thus the name EM. In the CSS specification, an EM is calculated as distance between baselines when the font is set without any extra space between the lines. For text with a font size of 16 pixels, an EM measures 16 pixels. For 12 pixel text, an EM measures 12 pixels, and so on. So I'll just show you a figure there. So as you can see here, an EM is based on the size of the text, but before I'll just make you understand this, I'll just want to note you one thing. that do not confuse the EM unit of measurement with the EM HTML used in the earlier HTML tutorials to indicate the emphasized text, and these two are both totally different things. So once the dimension of an EM for a text element is calculated by the browser, it can be used for all sorts of other measurements such as indents, margins, the width of the element on the page, and so on. When setting font size in EMs, the EM value work with a scaling factor similar to a percentage. In the following example which I am going to tell you, the body is set at 100%, okay, and we'll assume it the default of 16 pixels. Okay, so here you can see it is default the 16 pixels and 12 pixels like this, and this is 24 pixels. Okay, and just let me show you the example. Okay, so now I'll just save it and let's see what happens in the browser. Okay, so the font size of body is 100% and H1 is 1.5 EM. So I'll just tell you now the EM best practices. As of this tutorial, the most popular solution for making EMs display consistently is to set the body element to 100%, okay, which is keeping it at the default or user's preference. Then use EMs to size the text elements thereafter. So as I have done in the previous example, this preserves the user preferred text viewing size and yet ensures text elements are sized proportionally. There are few problems to working with EMs. One is that due to rounding errors, there is some inconsistency among browsers and platforms when text size is set in EMs. The other tricky aspect to using EMs is that they are based on the inherited size of the element, which means that their size is based on the context in which they are applied. So if you have many nested elements, the size increase or decrease will compound the each nested level. Okay, so I'll just tell you one example to make it clear. So just let's take the example now. Okay, this is our example, and say we start with documents body, okay, which is set to 100%, but we want an article to be only 14 pixels, and dividing the target which is 14 pixels by the context it appears in, which is 16 pixels, gives you 0.875 EM for the article font size, as you can see here. Okay, now let's say you want the H2 element in the article to be 18 pixels. This time the EM size is not based on the 16 pixel body text size. It is based on the article's element 14 pixel size, because that is the context of H2. So we divide the target 18 pixel by the content 14 pixel to get the final EM measurements, which is 1.28 571429 EM. So that is something value, and you can round it down, but leave at least 4 places after the decimal. Okay, so now let's see what happens in the browser. Now first let me check. Okay, so now let's save it and see what happens in the browser. Okay, you can see that, just wait, what just happened. Okay, it is now showing you the H1 is like this and H2 like this. So I just want to tell you that you should pay close attention while writing style rules in a way that it does not produce any compensating effects. So I'll just move forward to the next topic, which is pixels and absolute measurements. Although some developers prefer pixel font measurement for the precise control they offer. The predominant attitude is that they are good and too rigid, and that relative measurements, which is EM and percentage, are more appropriate to the medium. As long as we are kicking px to the curve, all of the absolute units such as pt point, pc picus, in inch, millimeter, and cm centimeter are out because they are irrelevant on screen. Okay, but they can be useful in printing style sheets. And another drawback to pixel font size values is that Internet Explorer, all the versions, does not allow text zoom or type sized in pixels. That means users are stuck with your 10 or 11 pixel type even if they are unable to read it. That's a big no-no in terms of accessibility. Internet Explorer 7 and higher do allow the whole page to be zoomed, which is an improvement, but it is not an ideal user experience. Okay, so now let's move forward to the next topic, which is working with keywords. The remaining way to specify font size is one of the predefined absolute keywords, which are extra small, which is xx small, then x small, which is extra small, then we have small, medium, large, then x large, which is extra large, then xx large, which is extra large. The keywords do not correspond to particular measurements, but rather are scaled consistently in relation to one another. The default size is medium in the current browsers, but the next figure which I will show you shows how each of the absolute keywords renders in a browser. Then the default text is set at 16 pixels, and I have included samples in Verdana and Times to show that even with the same base size, there is a big difference in legibility at all sizes, which are small and below. So let's see the figure. So this is the figure which I was talking about. Here you can see this is xx small, then x small, the small, medium, large, extra large, and extra large. Okay. The benefit of keywords is that current browsers won't let text sized in keywords render smaller than 9 pixels, so they protect against illegible type. On the downside, keywords are imprecise and unpredictable. For example, while most browsers scale each level up by 120%, some browsers use a scaling factor of 150%. The relative keywords, larger and smaller, are used to shift the size of text relative to the size of the parent element text. The exact amount of the size change is determined by each browser and is out of your control. Despite that limitation, it is an easier way to nudge type a bit larger or smaller if the exact proportion are not critical. So now let's see the next topic, which is font weight, or you can say boldness. After font families and size, the remaining font properties are straightforward. For example, if you want a text element to appear in bold, use the font weight property to adjust the boldness of type. As you can see here, the font weight property has many predefined values, okay, including descriptive terms such as normal, bold, bolder, and lighter, and 9 numeric values, which is range from 100 to 900 for targeting various weights of a font if they are available. Because most fonts commonly used on the web have only 2 weights, which are normal or Roman and bold, the only font weight value we'll use in this course in most cases will be bold, and you may also use normal to make text that would otherwise appear in bold, okay, to appear at a normal weight. The numeric chart is an interesting idea, but because there aren't many fonts with that range of weights, because browser support is very low, they are not often used. In general, numeric settings of 600 and higher result in bold text, although even that can vary by browser. Okay, so I'll just show you this how does it vary by browsers. So these are two type of text weights or font weights in two different browsers. The upper one here It is for Safari. Okay, and here you can see 600 is bold, pretty bold, and then this one, the below one, is for Firefox, which is in Mac, and here you can see the 600 is pretty lighter than the one on the Safari. So this was all from my side in this tutorial. In the next tutorial, we'll start with font style or italics. So thank you guys for watching. I'll see you in the next tutorial.